right, welcome everybody. Thanks so much for coming to a sponsored session on Thursday. Let's just suspend disbelief and all believe that we're not in a sponsored session for a minute because this is about the most not vendory sponsored session I think I've ever seen.
I'll buy that.
I'm Andrew Krug. I am lead security evangelist at Datadog, and I'm joined today by Alex. I'll let him introduce himself.
I'm Alex Hardman from the dev relations team at LaunchDarkly.
And he's going to be back to the stage in just a bit.
See you soon.
So you're in security incident monitoring, mitigation, and metrics, highly alliterative title, using feature flags. Just curious, how many Datadog customers do we have in the room today? Wow, the majority of folks. How many LaunchDarkly customers do we have in the room? All right, so huge intersection of customers in the space today. This is, in fact, a DevSecOps session, so hopefully everybody is primed to learn some things about security. So today we are going to look at how we identify security incidents in the cloud. We'll look at how some things have changed, how they haven't really changed in a lot of ways. I look back, and this is apparently my 8th reInvent, and a lot of these things that we're talking about are still kind of the same concerns we had from 8 years ago. Some of them are new. We have some new methods for doing incident detection, and then we're going to see kind of a demonstration of how we can mitigate some of these threats by using some cool new technology like feature flags. So the world is pretty different today than it was a few years ago. After all, we all took a bit of a break from attending reInvent in person for a we're back. We took a break from attending reInvent in person for a bit, and some things wildly changed. But some things really didn't, and I've sort of given a version of this talk multiple years in a row, and in 2016, kind of the hot topic was security automation, what we're kind of all calling security orchestration and response today. In 2018, we were talking about things like forensics automation, and then in 2019, we started to really think about how do we stitch this all together as this thing that we used to call runbooks and playbooks as code, right? So just keep that in mind as we think about how we're taking all this and bringing it all together so that we don't have to really think about each of these categories. So today you all probably have something like thousands of assets in your cloud environment. An asset could be something as simple as a file. It could be a workload. It could be a database. You have things that really increase the complexity of your environment. You have different methods of deploying things as infrastructure as code. You might have CDK, Terraform, CloudFormation, CDK that generates Terraform. It gets very complicated to reason about what the end result of that all really is. And that really increases our attack surface, because what we don't understand, we also can't defend. So there's kind of some trends going on that we've seen over the last 8 years, right? And that's that pretty much everything that is a cloud control plane incident always starts with some kind of credential compromise. And it might be something like a CI provider compromise. The thing that's building your code actually leaks some highly privileged credentials from your environment. Or it could be something traditional, like we've seen a real rise in phishing campaigns, for example, that target AWS SSO workflows. Or it could be something as well known as server-side request forgery, or SSRF, which feels like we've been talking about it forever, but it's still really an issue. The commonality here, even though we have new attacks, old attacks, credential leaks, is really that the attackers are going after the same stuff, right? They're going after more privilege in your environment, and they're going after the things that you store in the environment, like your customers' data, right? So that is the commonality here, is that we have sort of initial access, the target tends to be data, and when data leaves your environment in a way that isn't intended, that is a maximally impactful scenario. And when we do incident response, often the impact to the business is dictated by how long we actually take the business offline, right? And a lot of traditional workflows in IR are pull the plug, isolate the instance, take the system down. And that's well and good if you want to stop attackers, but it's not great if for a low criticality finding, you're still taking the business down and causing maximum impact. So several years ago, I was fortunate enough to attend a Kelly Shortridge presentation called Big Game Theory Hunting. I don't know if anybody else here is also a fan of Kelly, but she kind of does a lot of research at the intersection of sociology and security, and I was fascinated with this idea of using resilient systems engineering for sort of this game of cat and mouse in attack and defense. And the takeaway here from that presentation is that lots of classical game theory really can't be applied to defending our systems. We really have to think of this as kind of continuous security, continuous game theory, and we need to think about how a system can reorganize around threats in real time. And hopefully by now you've kind of seen where we're going with this as we start to think about how we might be able to use feature flags in order to do this, which is the focus of this talk. The unconventional application of leveraging feature flags to speed up your incident response process, engage your adversary, and disincentivize them from furthering their attack. So now I want to bring my friend Alex back to the stage here. He's from LaunchDarkly, and he's going to introduce you a little bit to the LaunchDarkly platform and share a little bit about how they use the Datadog cloud security platform to protect their business.
Thanks a lot,
Thanks,
Andrew.
Alex.
My pleasure. Thanks for the warm welcome. It's been a lot of fun working with Andrew. So a little bit about me first. Alex Hardman from the Dev Relations team at LaunchDarkly. I come from about 15 years of experience building in the enterprise for the financial services sector. So most of what I talk about here today comes from the pain I've lived with. And so a little bit about LaunchDarkly now. So LaunchDarkly was founded in 2014. And we started with a simple premise of being able to turn features on and off at runtime in your application. And it was built on the foundation of feature flagging as we conventionally think about it. But since then, we've moved far beyond that. We've moved to multivariate flags. So you can use JSON objects, string literals, or numeric values. We've got enterprise-grade security now, and we have a global flag distribution network that gets those updates to your connected SDKs in milliseconds. And even beyond that, our recent innovations allow you to get better insights into how your flags are being used, and then to further determine the business value and the impact of your changes in your system. So here's a quick look at LaunchDarkly's architecture in a very simplified way. Effectively, you have our flag delivery network, which is a collection of CDNs, and it's with over 100 points of presence around the world. And that's backed up by the LaunchDarkly infrastructure. And all the connected SDKs work effectively the same way. So an SDK at app startup time initializes by connecting to the CDN, getting the latest rule set, which happens in milliseconds. And then for each subsequent update in LaunchDarkly, it's broadcast to the flag delivery network and available globally in less than 200 milliseconds. So what do feature flags do? Initially, this was, what is a feature flag? But I think that answer ends up being sort of basic and uninteresting. What do feature flags do? They let us change the behavior of an app at runtime without having to change the application. So we can change the behavior while it's running. And so conventionally, we thought of that as enabling or disabling features, that classic toggle. But it's so much more than that, because we can change, because when we have multivariate, we can change rate limiting, we can change resolution, we can change content. And we can do it without having to change the application. And so feature management is a step beyond feature flagging. So it's not just that ability to change, it's all these other layers that wrap around it. And feature management, as you know it today, was pioneered by LaunchDarkly. And so people often ask me where we fit into things. And it's really hard to describe us. And so let me tell you a little bit about what we have on those layers around feature flagging. So we have contextual targeting. So you can target any user, device, by anything you know about them. Geography, entitlements, device, version. We've got ways that you can progressively roll out. So everybody's familiar with canary rollouts, but we've got the tooling to allow you to do that with any feature on the front end or back end. We have a comprehensive set of access controls. So within the LaunchDarkly platform, you can have your whole team in there and control at each layer who can change what. Additionally, so you can avoid those weekend releases and having to be up at night to ship code, we have workflows so you can automate that process. And because we want you to be able to span across teams of teams, we have interdependent flags. so that when you release a feature, if another feature is dependent on it, one won't go live without the other. And finally, I already mentioned the global distribution network, which enables those updates to reach globally very quickly. Okay, so a little bit about LaunchDarkly's scale. So we serve 20 trillion feature flag evaluations a day, which is a number that's staggering to me. It kind of blows me away. And I was working on this and trying to think of how to convey how big 20 trillion is. And so I did lots of fun math. I was trying to find how many grains of sand or how many stars. And then I think I was hungry, so I thought about M&Ms, and I think I came up with that it would fill something like 15 Empire State Buildings with M&Ms. But then Andrew gave me the best comparison yesterday, which was also very humbling. I'm astounded by 20 trillion a day, and he said, you know what, Alex, that's almost as many IAM identity evaluations that happen every second. Okay, humbled. And so how do we get to 20 trillion feature flag evaluations? We have 4,000 plus customers, many of them in the enterprise. You'd recognize their brand names. Underlying that, we have thousands of hosts serving this traffic, which makes for a considerable attack surface. So let's talk a little bit about that risk. Quick sip here. So our flag delivery network, that's that network that gets those changes globally in milliseconds. It's the beating heart of how we keep your SDKs up to date. And it's backed by our infrastructure. And it's not only our 4,000 customers that depend on us, it's all their users. And so we feel a great commitment and responsibility for that because all of you are likely impacted by this, whether it's on mobile or in the browser or on some service that you use. And so we take that very seriously, and we protect our infrastructure fiercely. And so let's talk a little bit about that. In particular, we use the Datadog Cloud Workload Security product, which lets us now, while we have defense layers outside of that, this lets us defend all the way down to the kernel. And it looks for anomalous activity everywhere in our infrastructure in ways that we couldn't possibly see it ourselves. So we're able to capture reconnaissance information and understand the nature of a vulnerability or access to the system. We're able, since we have such a considerable amount of compute, we're a great target for crypto mining, and so we're able to protect our compute resources from that. And because we're able to monitor down at the kernel level, we can look for rootkits and other attacks that we might otherwise miss. And so what we get from this is we get immediate insight. So in a process that used to be a forensic process, where we would look after the fact only to understand what had happened, now we see it when it happens. We're able to know where it's happening and how, where it came from, and so our security team gets deep insights and analytics right away. So they can quickly determine whether it's in fact a threat or something that we can ignore. Right, so we came back to crypto mining as a great example because we will never have that in our environment. But also because we're a novel SaaS platform, we have a variety of different things that we need to monitor for and risks that we have. So given that flag delivery network, we have different kinds of exposures. And so because we've got those thousands of hosts and consequently millions of data points, it's humanly impossible for us to see all of that and understand it. Also, the attack surface is huge. Between APIs and the internal resources, there's so many different places. So the monitoring and detection at the endpoint is key for us. Additionally, because you look at the volume that we operate at, being able to quickly determine, one, if there's a credible threat and address it, or that a threat is not, that we're not vulnerable to it, is essential. And so from these thousands of hosts and the monitoring that we get with the cloud security tooling, we get double-digit actionable true positive alerts, which means we're able to sift through data, sift through all that noise, and come up with something that actually matters that our security team can act on. So one of the essential parts of having a robust security culture is having your development teams and your security teams speaking the same language. And if you're in an environment today where your security teams are separate from your development teams or they're using different tools, they don't share a common view of the world. Our development teams are already using Datadog to observe and understand the health of our systems. So it's a natural extension that the security team would also use that same system and use the same semantics around monitors, alerts. And so the other thing we have at LaunchDarkly is we have this robust engineering culture, which helps us ship and evolve quickly, but also we have this eye to security. And so our security team is made up of software engineers who have a deep understanding of what we're working on, where we're headed, and so when they identify new risks or new vulnerabilities, they're aware not only of the concern, but also what drove them there, and they work closely with our engineering teams to resolve. All right, so now we'll go back to Andrew, talk a little bit more about rethinking detection.
Just to go back to that breaking down silos comment for a minute, that is in the way that we think about building every single one of the products that we build at Datadog. Our goal is really not to create security products that are for security people, right? It's to create security products that unify that security view using observability data, because we want our engineering teams to be concerned with the security of the products that they're building. I don't think anybody gets up in the morning and goes to work and says, you know what I'm going to do? I'm going to introduce a vulnerability to this application. So we really try to bake that into the way that we think about detection, response, and observability. So let's think a little bit differently about how we would do detection of a security event inside of our cloud environments. If you've interacted with many threat detection engineers, and maybe you have your own, most of you probably don't, I would guess, you might be familiar with the pyramid of pain. And if you have been at security conferences this year, security people love pyramids. This pyramid shows you all of the different indicators that we can use to detect threats and how painful it would be for an attacker if we can actually just deny them these things in the system. So don't pay too much attention to what's below TTPs up there. That stands for techniques, tactics, and procedures. So that's describing the behavior of an attack instead of doing things like just blocking IPs or blocking file hashes. And this is kind of the direction that the industry is trending, right? We describe threats as TTPs, but we also want to block things using TTP-oriented defenses. So I created my own pyramid in the spirit that security people love pyramids. And this sort of demonstrates the pyramid of pain inside of the cloud, right? And that is that it is super easy to have CloudTrail. It is kind of annoying to have to roll out a new agent to 100% of your endpoints, and it has been historically very challenging to get developers to put security controls inside of the application stack itself. So this looks like an opportunity for product market fit, right? Which is that if we want devs to adopt tools like what we're going to show on screen, it has to be incredibly easy for them to put it in their app. Think security easy button. For endpoints, we've already kind of solved this with paved road concepts. We can bake those things into our AMIs, right? Like maybe it's inconvenient, but we can do it as long as we know it's the right agent we're deploying. And these days, with the 7 days free of CloudTrail in all new accounts, we can kind of assume that we have the ability to pull in and detect using CloudTrail. So for years, we've been talking about these phases of incident response as they map to this framework from NIST. I don't know if anybody's ever seen this before, but they're detect, protect, respond, recover. We kind of use this as the defender's answer to the phases of a cyber attack. And on the detection side, of course, we have everything that's part of Datadog Cloud Security Management. On our side, as far as doing detection, we can kind of take it to the bank. Those out-of-the-box rules are going to fire for actionable things. As far as protect, respond, and recover, that has historically been up to you, right? And that's where we can really use flag delivery. We can do things like instance isolation, which is, again, that more traditional workflow. For response, we can also use flag delivery in response, though I'm not sure that we see a lot of people doing it today. And for recovery, that's your post-mortem process at the end of the incident, repatch, redeploy. Maybe you have a way to dynamically inject code as sort of a intermediate recovery step. But just keep these concepts in mind as we kind of look at our use case here. So since we can't show you the inside of LaunchDarkly, Alex and I collaborated to build a sample app that we're calling TravelDog. which is based on some incident trends that I've seen over the last like 5 years or so. And we try to build this on a standard architecture, but also put some really new things in it. Because I think one of the traps that we fall into as practitioners is we say, oh, well, that's too new. I can't do forensics on it. I can't defend that. I can't do incident response on that because it's just so bleeding edge. In the forensics automation talk that we did, we actually did it on top of Fargate because nobody thought that you could really do forensics and IR on Fargate. It turns out that was myth too. So the architecture for this app, really, really simple. It's just running on ECS on EC2. But our net new spin is that this is running on Graviton ARM instances. Originally, it wasn't going to be on Graviton, but I upgraded to an M1 Mac. So I wanted to be able to build my containers and then just deploy them straight to the cluster without VMs. So Graviton it is. It has a Dynamo table containing some user data and an instance role kind of as part of the deployment. This is a really simple app. If we wanted to just go out in the hall and make a startup today, this might be the architecture that we settled on. I don't know. Our goal for the business is to allow dogs everywhere to share and showcase their favorite place to travel and be an index of the dog-friendliest places on Earth. So business goes really well, right? You launch the app, business goes really, really well until, can anybody guess? Feature requests. We're all familiar with feature requests, right? Because doing well is never enough. We have to do better than well. So our users have asked us to introduce some features using the feedback form. As a user, I should be able to edit my profile to update my favorite place in star rating. Seems basic enough, right? All users see the most recent 5 updated listings on the homepage. So we want to showcase the most recent 5 active travelers. And security engineers and technicians want to be able to run arbitrary commands on these systems without the use of SSH. So we kind of have a little bit of an ops engineering security story in there as well. So you might be asking yourself, what could go wrong? It all sounds very well-intentioned, but depending on the execution of that implementation, we could potentially introduce some pretty broad attack surface here. Just to kind of show you what the site looks like, and I do have it live, and I am going to do a live demo because we are all in the same room. I'm not just going to show you videos. This sort of demonstrates a little bit of the functionality here, which is that we have authentication, sort of a very simple authentication. We have a change log feature in here in addition to those things I just described. And we have that profile editor there, which also allows users of the site to put in their favorite travel site URL, and then it's going to show them a preview of that site in a screenshot on the profile. And for transparency to our user community, because we are good developers, we also added a change log. The problem with the change log is if you're an attacker, the change log can sometimes be a really great place that we can get information about how things work, what routes the API has, and what the behaviors of those things are. So this is kind of a public data leak of functionality in the site. This all seems really, really normal. If we were to turn this and look at it through the security lens, and I didn't ask how many people would identify that they're primarily in a security role, but I would be curious if you just want to self-identify. Not too many. So this is great. This is all brand new stuff. So if you are on a security team and you're reviewing feature requests as they come in and the output of those, you do this thing that's called a risk assessment. And we'll talk a little bit more about how to do that and threat modeling in just a bit. But each of these features has added a little tiny bit of attack surface, right? We have this profile editing feature, which also added a endpoint that's for development use only, that will leak some information about the users. That image preview service, anytime that we start screenshotting things and put them in an app, that's like pretty ripe for a server-side request forgery. And then we also have the systems manager agent on these things, but whomever wrote the task role for this just kind of hacked it on rather than adopting the AWS managed policies, and that hasn't been caught either. So we have a variety of risks as part of this. So if we were to walk through these individually as threat scenarios, we have this seed route, which you have to get some users in an app for demos. This should only ever be on in development. It's supposed to create 100 users and then return a paginated user list from the database. But as we know, configuration management can be really challenging, right? And this is all written in Python, but I'm sure if you've reviewed enough code, you've seen things like this in real life, which is that conditions for configuration management tend to proliferate, right? We have all of these different ways that we can embed conditions in code, and conditions make more conditions, which make it really hard to reason about what's going on inside of a block of code. So as a concerned engineer or as a security person, sometimes we miss things. And eventually, somebody makes a mistake. You have this feature in your application, only ever supposed to be on in development, and then development becomes production. The problem with this, in this case, is that when development becomes production, it starts leaking personally identifiable information about our users. The answer to this is to do some kind of lightweight threat modeling. And a lot of people don't think that threat modeling is practical at scale because threat models take a long time. But building a lightweight threat modeling process into your process as part of a technical design review, like the Mozilla Rapid Risk Framework, will give you really, really good insight into kind of what the potential risks are as part of a feature rollout. And I can't stress this enough. This is a great framework that you can just pull into your TDD process. So what we can do as an output of that is we can actually ask our engineering teams to think about worst case scenarios. Some people call this table topping, some people call it risk assessment, threat modeling. It goes by a lot of names. But the output of this, if you're a customer of a platform like Datadog, can actually be detection rules. And you can have your engineers contributing detection rules as a part of a feature rollout. And so in our case, let's pretend that we actually did an RRA, rapid risk assessment, at TravelDog. And the business wanted to keep the feature in the app, even though it was flagged as a risk. So the compromise is that the DevSecOps folks, or your engineers, because we're all DevSecOps folks, write a detection rule to detect that behavior. And so then we can actually use that detection to ask a platform like LaunchDarkly using a webhook to just go and disable that feature in production should it ever make it there. That's pretty cool. So then, instead of getting data leaks, the attacker just sees that that feature is actually flagged off. So I think you can see where we're kind of going with this, that we have this great integration with LaunchDarkly that was originally for ops, because sometimes we roll things out, database query or whatever, might take the system down. So we just want to webhook out, we want to flag it off when things go bad. Security tends to be a lot of the same use cases. So if you want to go back to your place of business and see, how successful are we at doing something like what I just described, I like to measure, put simply, developer friction. Like how hard was it actually for an engineering team in pursuit of the rollout of a feature to do this? And the way for this I would measure developer friction is to say how many flags are in the product that are protected by a platform like LaunchDarkly, and then how many risk or threat assessments did we do, and then how many detections per feature did we contribute back to a platform like Datadog Cloud Security Management. That all makes sense, right? So in threat scenario number 2, this is actually going to get a little bit more complicated. And we only have time to really show you 2 threat scenarios from that list today, but if you want to see more features from this vulnerable app, definitely let us know. We might have an upcoming webinar. But we'll go ahead and look at this. But I want to take you back to this idea that all of our response should be to create a system that is more flexible, adaptable, and transformable than simply turning an entire feature off or turning a system off for 100% of your users, right? And that's really what we want to take away anytime that we're thinking about building feature flags into a system like this. So that is the ability of the system to reorganize around a threat. So we got the detection side covered pretty well, right? We have all of these different things that can detect through the full application stack. So SIMs, what we call security information event managers, those are kind of what all of us started with. We started rolling these things into enterprises 10, 12 years ago, and there's a lot of SIMs on the market. But what we've seen is the rise of continuous monitoring of things like configuration, like let's detect changes to the environment that are less in favor of security or might cause a potential data leak, cloud workload security, detecting things at the endpoint, and then what's brand new, what you might all be interested in, is actually embedding these things in the application itself using something like application security management, which is what we call it at Datadog. It literally sits inside of the application stack itself. So for a long time, we all talked about WAFs as being the ultimate answer to this, or web application firewalls. That's moved one step closer to the application itself, because if we're sitting in the application runtime, we can do many more heuristics on attacker behavior, and we can really start to differentiate what's normal and what's not. And I think what's very cool about the Datadog implementation of this is that it's actually built on top of Datadog APM. So if you already have APM in your environment, it's literally a single flag to enable the AppSec tracer in addition to APM. And then when things get really bad and an attacker bypasses your application and manages to pivot to the infrastructure, that's where the cloud workload security component comes into play. So you might have something that is innocuous on the outside, like a SQL injection or a local file inclusion that leaks some source code. An attacker might use that to escalate to remote code execution, and in that case, you would want a workload security finding. And sometimes, as we all know, there are zero-day vulnerabilities. And if you paid any attention to the news this year, there's been the OpenSSL vulnerability, Log4Shell, Spring4Shell, Text4Shell. There's probably a 4Shell that's come out during this talk that somebody is writing about right now. But it seems like we're dealing with these things almost every other month. And that doesn't require your engineering teams to make a mistake. So it's a little bit of a two-pronged approach to detection. So back to that application security monitoring example. I would assert that most of the applications that you're building for the web are a little bit like a good piece of chocolate. And that's that they have hard on the outside and they have all of the squishy center on the inside. And that's a very long way to say that most of the business logic in your app is behind an authenticated route. I don't know if you would agree, disagree, but most people at least have some concept of tracking authenticated sessions to see what you can do inside of an application. So if we go back to our demo app, inside the demo app, we have some information that's been leaked about the application itself. We have data leak, an SSRF, and the inclusion of this thing that we call a command injection, which is where the app actually shells out to a sub-process to execute something on the command line, and we can just arbitrarily ask it to do more than was intended. It'll carry that out and return also still, oddly, the desired response. So what do we have as tools? We have Datadog ASM, which can actually alert on authenticated user behavior, not just unauthenticated user behavior, because again, we're always going for actionable alerts. We want to be able to correlate that back to a person, an IP. We want to know that an attack was successful, not just that it happened. Remember in the 90s when we all turned on our firewalls and we said, oh, I blocked 100,000 attacks. And that was on a dashboard somewhere in every security operations center. I don't care about the attacks that we blocked. I care about the attacks that got through, because those are actionable. And on the LaunchDarkly side, we actually have this method that we can use to track and correlate user sessions and then target specific behavior for specific users. The way that it works is super easy. That one singular line right there below the method is all we need inside of this Python app to just correlate the APM user with ASM and also LaunchDarkly. So you'll see the LaunchDarkly flag evaluation right below that. So just that tiny little bit of code lets us wire up those two really important data points. And I did champion kind of the webhook integration for turning flags on and off earlier. But if you want to do something a little more complicated and a little more fun, we can chain together some serverless stuff, right? And that is one of the more powerful ways that we can integrate with LaunchDarkly today, which is to take a service like the one I'm going to show you. That service is going to emit telemetry to Datadog. Datadog has a great integration with AWS EventBridge, or Amazon EventBridge. It can emit any event from any monitor inside of the platform as the full JSON payload to EventBridge. You can, of course, send that to a custom Lambda function, and then that Lambda function can do stuff. And in the case of our example today, we're actually going to use that to enable and disable features specifically for a single user inside of LaunchDarkly. Just to show you how rich those events are that come into EventBridge, and don't worry if you have to squint too hard. The point is just that there is a lot of information that comes through from Datadog and the EventBridge integration. Everything that you would need to respond and recover is in there. The things that we care about for our purposes in this example is this much. We care about that rule ID, what rule fired and actually detected the threat, and we care about the correlated user, which is actually coming through from that APM trace line that you saw earlier in the presentation. And we are going to use that to do this crazy thing that is called adversary engagement. Has anybody ever heard of adversary engagement before? This is a brand new kind of domain with regard to how we're handling cyber threats. MITRE actually has an entire engagement matrix for the different ways that you can kind of mess with an attacker as they're progressing through your system. And you might be asking, why would I want to mess with the attacker versus blocking them? Well, you get to learn a lot more about them, and you might get them to reveal some cool tricks that they didn't want you to know about just yet by engaging them during a threat. So this is kind of a brand new, cool, emerging space in cyber. And if you want to see a great talk on engagement, because we don't have a lot to cover it today, and I do like to give credit where credit is due, this is an awesome talk from last year's ShmooCon called She Doesn't Even Go Here from the MITRE Engage team. It is Mean Girls themed, and it is hilarious. So all the way back to that, we want to take these rule IDs. We have the rule ID, the thing that's actually detecting in Datadog. We want to take that and map it to a specific risk that we've identified inside of our app, and then we want to take an action, which is going to be to engage the adversary in some way. So I've created this table here that's actually showing you what the rule idea is, what the risk is, and what the action is that we're going to take. So this is where I'll actually switch to the live demo, but just to show you, we have this profile editing feature here. And the profile editor allows you to arbitrarily update the URL of your favorite site. There we go. It allows you to arbitrarily update the URL of your favorite site. So what I've done here is I've actually updated it to be the metadata server URL of the container. I am giving things away. And the attack itself just looks like this. It's just a regular command that posts to that API route that was described earlier. All it's doing is updating that. And then what it's going to do is it's going to take a screenshot of that, which would normally be the favorite travel site. And instead of returning the favorite travel site, it's going to return, and this was just me kind of poking at it a bit until I got the right thing, just like an attacker would. And then boom, we got credentials. So that is, in a nutshell, an entire SSRF. So when that happens, what's going to happen inside of the Datadog platform is it's going to actually detect that as an SSRF attempt. And if we want to look at the APM trace that's correlated with that, and apparently somebody is actually attacking this app as we're doing the demo, might think it's WordPress, might not. Or we could filter down. We could say, just show me all the SSRFs. I can see the correlated session right here, and I can see the user that committed that attack because it's correlated to the session, and the session is part of that trace again. So what we can do in order to respond to that threat is we can actually fire off some code, and I have this in a Lambda function that is wired up to EventBridge, but just for the purpose of the demo today, LaunchDarkly has this great API for Python that you can use to integrate with the REST API. That is 100% of the code that it takes to respond to this and activate or deactivate a flag trigger inside of LaunchDarkly. So what we're going to do here is we're actually going to run this bit of code just like it would have if it was triggered by EventBridge, and this would be the username that's actually yanked out of that big old JSON blob. So let's go ahead and run our response here. So I'm just going to pretend I'm a Lambda function. Ta-da! And now, instead of being a regular adversary on the site, I am a identified adversary. So now instead of returning dogs, it's returning cats. So that's pretty cool, right? But I've also activated a fun feature in here, which is actually going to mess with the attacker a little bit, and it's going to start to let them think that they have compromised this app in a more significant way and waste their time a bit. So this may be a little hard to see on screen here, but in our regular personally identifiable information, we started to return fake social security numbers or fake credit card data. And so we're wasting a bit of their time in the sense that they're going to start yanking down all this information and checking to see if these SSNs are valid, seeing if the credit card number is valid, and they're all, of course, not valid. So you can start to kind of think about different ways that you might be able to use feature flags to engage the adversary.
So, and just to extend what you were saying about, authenticated users and attack and being able to identify folks by username or attackers by username, the other thing is that in the LaunchDarkly platform, you can target by anything you know, right? So if you have an unidentified user, you could target by IP address or range or a variety of other criteria. So if you can't pinpoint by identity alone, there's a number of different ways. One thing I wanted to mention that Andrew said earlier was about how conditional statements in your code make code harder to understand. And one of the things you'll see, and so there's this code here, and I think this one is not actually where we're using the feature flag, but one thing you can do by using feature flags in your code is make it more configurable to change at runtime, thus making it more resilient, and you can reduce the conditional statements when you use multivariate flags to configure your application.
So we're not done yet. If you don't have somewhere to be, you might not want to run just quite yet. So we exploited that feature, right? And we saw how we can kind of respond and do something that's slightly annoying to the attacker, right? We went through this entire example of executing that SSRF, which a lot of people have never even seen in real life, a real-life SSRF. And the result of that, we use that fake data to waste the attacker's time. And that is based on the assertion that you as a defender, you're busy. You want to roll out features. You don't have a lot of time to think about this stuff. Somebody that really wants to take your business down, they have effectively infinite time to think about the way that they want to mess with you and then attack your system. So if they have time to study your app, time to craft their attacks, we just want to make that as economically expensive as possible and learn as much about them as possible. And that is kind of the basis of adversary engagement. Another way that we could do something kind of fun and interesting is we could actually think that they are having a performance impact on the app. And we could just start doing this thing that we used to call tar pitting, which is just arbitrarily increase the amount of time that it responds just for that user that's been identified as a threat. That's kind of fun. Again, this is only possible because we can correlate that user session, and then the session cookie becomes the ultimate decision maker in terms of the user experience. So while everybody else is getting the normal site, your attacker is going to have a real bad time and get real long responses from everything. And we might not always decide to do this. It's going to be based on the risk and the criticality of those alerts, which should always be mapped back to, like, what is the application doing? What is the risk to the business from that behavior? So we just showed you injecting the fake canary data. Another fun thing that we could decide to do is maybe we just want to activate a flag and try to hire this person. This is pretty outside the box thinking, but stay with me here. Even if you don't want to try to hire people, you might have a bug bounty program. I don't know how many people either outsource or run a bug bounty program on their own, but just redirecting somebody and saying, actually, you can make more money over here, you might turn them to your cause instead of actually having them as an adversary on the outside. And then again, when things escalate, and I will do this demo on screen in just a second, you have cloud workload security to determine that person is a maximum risk, and then you can go into that traditional incident response workflow. Who here has ever seen what a Python reverse shell looks like in real life? Few people, the majority not. I thought it would just be fun to show you actually how arbitrary and simple it is once you discover a command injection. So we have an example of a Python reverse shell here. think this is the one, attack 4. Yep, this is the one. And so what this has in it, arbitrarily, is a whole bunch of really dangerous-looking Python subprocess and socket statements that are URL encoded that are going to be passed to a parameter, and then it's going to spin up a Python subprocess that's going to phone out to a netcat listener, and then that's going to give the adversary a reverse shell. So when we actually execute this on the system, it does not like that syntax. Probably I didn't escape something quite right. There it goes. Oh, nope. This is the danger with live demos. There, it just executed. We just executed a reverse shell arbitrarily using a command injection inside of that Docker container, inside of the ECS cluster. So now what we're hoping is that we have a finding in cloud workload security that says, hey, that's really suspect. So just to show you what that looks like, if we dive in, Python executed with suspicious arguments. And of course, this is a maximum severity finding. We pop this open in workload security, and we actually see every part of the process tree in terms of how that subprocess was executed. We can even tie it back to the specific container on the specific instance, which is one of the hardest things in incident response when you have thousands of hosts like Alex does, is to know where was the thing inside of the environment. And so this is when it's maximally bad.
So one of the things about understanding and identifying instances and being able to drill down like this is back to that targeting example. One of my favorite operational use cases with LaunchDarkly is to set log level through a feature flag. So, since I can have such granular targeting, I could target an instance and capture more data or capture logs for a particular user.
Yeah, so this would be about the point in the flow of escalation with the attacker where we consider we can't turn them to our cause, we haven't annoyed them sufficiently, they're a maximal threat to us, so now we do actually need to pull the plug, ramp up as much instrumentation as possible, and then go on with our life. So inside of Datadog, for every finding, we have this incident management workflow tool where you can just click declare incident. It is the exact same tool that operations folks have been using for a long time now. So we've unified this concept of security incident response with operational incident response. And we can page out the same notifications. It captures every bit of the forensics artifacts. I've got this all workflowed out in the slides here. So we can declare an incident, we can follow the traditional flow, and we can increase severity as we figure out that more and more bad stuff happen inside of the system. It spins up that incident timeline, which is very, very cool and very, very useful if you ever have to go back post-security incident and talk to lawyers, talk to auditors, do a post-mortem with your team. And a brand new feature that you can go and see today at reInvent is the integration of a product called CoScreen, which is a company that Datadog acquired a short time ago that allows you to collaborate in real time. It's optimized for screen sharing, not for video calls. This is supposed to be an application that you can use for maximum collaboration on a piece of code. Everybody can see each other's cursors. You can have multiple people clicking on things and editing things. It's actually incredibly useful during a security incident to just get everybody on a co-screen together and then start to process a document or go through the forensic artifacts of that. So if you do decide that you want to go back to work and implement this, and we did promise metrics, the metrics that you could use to see how am I doing at this as time goes on is to measure on 2 dimensions. We can look at the engagement performance. How good are we actually doing at identifying the criticality of an incident and involving humans? So that's incident volume by criticality. And how many tabletops are we actually running with the engineering team? That, again, is the risk assessment or kind of a threat scenario process. You can make it your own. On the actual responding side, keeping the business alive, this is weirdly the same as operational incidents. We want to look at what was our average time to detect something that was real bad, and what was our average time to respond and close out a post-mortem on that incident. So in summary, and we are going to have some time, and we'll be able to take questions at the end, we can use non-traditional tools for security workflows, feature flags being one of the ones that hopefully now you all are inspired enough to put in your tool belt. You can challenge your software teams to model risk and contribute detections back to whatever your cloud security product is. Maybe it's Datadog, maybe it's something else. And you can use this fun new thing that's an emerging space in cyber to do things like adversary engagement and annoy your attacker potentially before you have to take the entire system offline, or they escalate to a more severe pattern of behavior. All the links that you saw in this talk, along with all of the code that you saw today, which is, by the way, fully open source right now, is available at the link on screen, along with different ways that you can get a hold of me. And I think one of the best things that you can do after a session is actually ask me questions after the event, because I would love to know, did you love this? Did you hate it? Do you think it's interesting? Should I build more demos like this? Should we have Alex back? Yes. And if you want to see CoScreen, that's at the latest innovations booth, which is just off to the side of Datadog. And I'm sure every person here knows where the Datadog booth is in the expo hall. Again, thanks for being here today. Let's give Alex a hand.
Thank you.